Hello everyone. Today we'll be going to solve the question remove duplicates in a sorted as well as in the unsorted linked list. So these are the questions we'll be going to solve this. And I know I haven't been uploading videos from the past 1 week because I was busy solving questions on linked lists on various platforms. So sorry for that. And now let's move towards the question. So here's the question. Remove duplicates element from a sorted linked list. Given a singly linked list consisting of n nodes, the task is to remove duplicates, nodes with duplicate values from the given list if it exists. Try not to use any extra space. Expected time complexity is big O of n. The nodes are arranged in a sorted way. Alright, so let's take a look at this linked list. So the linked list is 2, 2, 4, 5, and the output should be 2, 4, 5. There shouldn't be any duplicacy in the output. So each and every value should be unique. So we need to make delete the duplicates element from the sorted linked list. Take care of the fact that we need to delete the nodes from the original linked list, and we shouldn't create a new linked list, right? So take care of this fact. So in this example, the linked list is this, and the output should be 2, only the unique values, right? So let's have a look. So this is one of the easiest question you can find in the linked list. It's very easy. There's I'll explain you how I'll be going to solve this question. Right. So what we'll do is we'll start with the head of the linked list as usual, and what we'll do, we'll check if the next node of that value is same as the current node. If it is, then we'll simply delete the link of that linked list and point towards the next towards the means next element. We'll break the link between the elements if there's an duplicate elements, and there's a fact that the linked list is sorted, then we'll probably get to know when we'll get duplicates element in a linear fashion, right? So for example, head is over here right now. Head is over here. We'll start from here. Pardon me for this writing. This is the head, right? So what we'll do, we'll check if the next node of this current node, we'll make a temporary node, and this is what we'll use to iterate. So we'll check if the next node is same as the current node, the value of the next node is same as the current node. If yes, we'll break the chain and we'll point this towards this, and we'll again now check if this temp node is value is again greater equal to the next node. If yes, we'll break the chain from here and we'll point towards here. Now we'll again check if the temp value is equal to its next value. If it's not, we'll increment temp, and now we'll apply the same process from here onwards. Yeah, so there's nothing much to explain. It's very easy question. Now let's try to code this. So uh, let's try to code it. So we are given the head of the linked list. So what we'll do is first of all make a temporary node, make it equal to head, and start with the loop while temp.next not equal to null, right? So now what we're going to check, if temp.data is equal to temp.next.data. If that's the case, what we'll do is we'll simply break the chain from the current element and point towards the next element. The next element, what I mean by next elements, the next element to this one. For example, the temp is over here right now. We'll break the chain from this and point towards over here, right? So what we'll do is we'll do temp.next equal to temp.next.next. That is what I'll be. And if it's not, then what we'll do else, we'll simply increment temp. What we'll do, we'll move the temp forward. Temp equal to temp dot next. Right, simply remove this curly braces. No need of curly braces. Right, so this is the whole code for the this problem. Also, if head is the only element we get from this function, for example, we only get 2 as the head, then what will happen to this function? We'll get temp equal to 2. For example, the input is 2, let's say, just 2, right? We'll get 2 from this, and we'll point to equal to temp, and we'll see temp dot next not equal to null, right? So it's not equal to null actually, and what we'll do is we'll return, so we'll simply return head. There's no need to do anything else. So let's try to run this, compile it. 2 4 5, yeah, it's working fine. Okay, let's try to compile this one as well. Output should be 1 2 3. 1 2 3, correct. Let's do for 1 1 as well. Yeah, it's fine now. I think it will be submitted. Yeah, so problem solved successfully. So this was one of the easiest question in the linked list. Nothing much, just increment, delete the chain from, means just make the temp dot next appropriately, and you will solve this question easily. Nothing to worry much. So now, what's the next question? The next question is remove duplicates in a unsorted linked list. So here's the question. We need to remove the linked list. We need to remove the duplicates from an unsorted linked list. Let's have a read of this question. Given an unsorted linked list of n nodes, the task is to remove duplicates element from this unsorted linked list. When a value appears in multiple nodes, the node which appear first should be kept. All other duplicates are to be removed. Right. So this is the same 5224. Nothing much to read about it. So expected time complexity is big of n, and auxiliary space is big of n as well. So let's say, so now this question says that there is no sorted order maintained in the linked list. The linked list can be sorted or cannot be sorted. There's no guarantee about that. So what? So let's take a dummy. Let's take a test case 5224. So 5 2 2 4. See, now what it is given is there is no sorted orders. That means we cannot, for example, if we are at here, we cannot guarantee that there will be another 5 or not. So we don't know whether there is another 5 or not. So in this case, we'll use another data structure, maybe set or maybe map, according to you. Nothing to worry about it, but we'll use another data structure to get where we'll put elements, and at the time when we need the data of some elements, we'll get from that data structure. So in this case, whenever questions comes that the element should be unique in the answer and all, once data structure that comes to our mind is set. So what is set? A set allows only unique elements to be present in that itself. Right. So what we'll do is we'll start with the linked list. We'll iterate, and as we are iterating, we are also adding it to the set data structure. And if there is already the element that we are going to add it is present in this set, we'll just update the links accordingly, and that will help us to delete the duplicates from these unsorted linked list. Right. So for example, we are at here temp, and what we do is we'll check if there is any 5 in the set. No, there is no 5 in the set. So let's make a set data structure over here, just for the sake of example. The currently set is empty, and now we'll check whether 5 is present in the set. No, it's not present. If it's not present, we'll add it into the set, and we'll move the temp over here. We'll check if it's 2 is present or not. No, it's not present. We'll simply add 2 over here and move temp over here. Now we'll check if 2 is present or not. Yes, it's present. So now what we need to do is we need to delete this linked list, right? And to in order to delete this linked list, the previous node should not point towards this. Instead, it should point towards this, right? For this, we need to make a previous pointer, a previous node, which will take care of the fact will if there is any duplicate element, then we'll update the previous node accordingly, right? For example, here in this case, the 2 was present earlier in the set, so we'll need to update the previous address accordingly, right? So that's the explanation for this question. Now let's try to code this. So what we'll do, we'll make a set data structure. Set integer, will take integer values. Let name it as set new hash set. Yeah, we'll point node temp equal to head, node previous equal to null initially, right? So these are the nodes where the variables or the instances of that class will be going to use, not instances. Yeah. So let's start with the loop. While temp not equal to null, what we'll do is we'll check if set dot contains temp dot data. Yeah, if set is containing that, then what we'll do is we'll simply previous dot next equal to temp dot next, and then what we'll do is we'll do else. If it is not present, we'll update the previous pointer accordingly and then add it into the set. Simple and easy, right? And then after temp equal to temp dot next, return head. So you guys might be asking that why I haven't made the previous add as head initially. For example, if there is a reason why I haven't made head previous as head, or we can make it. There's no problem with that. For I have made it because I know that for the first element of the linked list, it won't be in the set, and then we'll come towards this loop in this condition, and then it will update the previous accordingly. Right. So this is the whole code, simple and easy. Let's try to compile it. What's the error? Previous .NET. Okay. Compile and run. 524. Yeah, it worked fine. Let's try to run for this test case as well. Yeah, it worked. Compiled successfully. Output is correct. Let's make another 5 1 1 2 2. My output. Yeah, it's working fine. Now let's submit the code. Yeah, so the problem solved successfully. Right, so that is what. So what you need to take from this question is, if there is no sorted order and you need to do something with the unique elements, then set is the appropriate data structure. You can use the set data structure to, and you'll be adding the elements while iterating through this linked list, and keep on checking it accordingly. Yeah, so the time complexity of this solution will be big O of n. You are iterating to the linked list, big O of length of the linked list actually, which is n indeed, and the extra space which you are going to use is big O of n as well. So thank you.